Okay, so we start with the square drawn in perspective. We draw the diagonals to find the center of the square, and then what? Maya?
Don't you draw like a line from the vanishing point down to the middle?
Okay, why are we going to do that? You forgot it? Okay. So let me draw a picture of what's going on here that's not in perspective. So we're starting with a square, and we find the center of that square by drawing the diagonals. And so now Maya says we need to draw a line going to the vanishing point through the center of that square. Why would we draw a line going to the vanishing point? Going through the center of the square. Why would we draw this line right here? Allison?
It cuts the square in half.
It cuts the square in half, exactly. So we know this is the center of the square, and we go to the vanishing point because I know this line has what relationship with these two? They're parallel. Remember, parallel lines in perspective go to a vanishing point. So since this line needs to be parallel to these two, we're going to go to the vanishing point, and since it goes through the center of the square, that's going to cut the square in half. What if I want to cut the square in half this way? What should I do in that picture? Draw what kind of line? A horizontal line. So it's a horizontal line on this picture, and it's going to be a horizontal line there because the width is not drawn in perspective. So those lines do not need to be drawn to a vanishing point. So we get these two lines here, and what we have now is 1, 2, 3, 4 squares. Our goal is to get 16 total. Instead of 4, I want 16, so I want to split these up into 2 by 2. So what should I do next to split those smaller squares up? Tiffany?
Don't you have to draw, like, I don't know what it's called, like a line? Is it like the line that goes through the bottom right to the top middle line?
We don't need to do that. We would do that if we were trying to construct an adjacent square. So if we were trying to construct another square up here, then yes, we would need to draw the line. What Tiffany's saying is draw the line from this corner here through that intersection to where it intersects here. And we would need that if we were drawing an adjacent square here. Okay? Okay, yeah. So in these squares here, since I want to split these up into smaller squares, so now I want to take this square and split it up into a smaller square, I'm going to draw the diagonal in there. So I'm going to draw this diagonal here, which tells me where the center of this square is. I'm going to draw the diagonal of this one here. And actually, that's going to be enough for what I want to do. Anybody have any idea why I don't need to draw these diagonals up here? Raven, what do you think?
Well, because you know that they're like the same point. Like, if you were to draw a line through it, it will also go through the middle of that way.
Yeah, I think you've got it there. So what we're going to do is we've got the centers this way, so we can draw the lines going to the vanishing point and split it up this way. Right? So we can draw these lines to the vanishing point here, and then those lines we know have to go through the center of these squares here. Is that what you meant?
Yeah.
So now we've got an intersection with this diagonal here that's going to tell us where the center of that square is. So what we've got now is 4 squares going this way and only 2 that way. So what do I need to do to get the horizontal lines in here? Not a trick question.
Just draw a line.
Draw horizontal lines. Now, those lines have to go through where?
The points.
Yeah, they need to go through that intersection and that intersection here for this bottom one, and they need to go through this intersection and this intersection for the top one. So we're going to draw in 2 more horizontal lines there, like that. And have we done what we wanted to do now? Do we have 4 by 4? Yes. I'm going to ask you to do 8 by 8, to do a full checkerboard or a chessboard. So you're going to do something like this. Brittany, can you see that over there? Okay. So you're going to do something like this where you're going to split it up into 8 by 8. So what would you have to do from this point if you want to split it up even further? Draw more diagonals. So draw a diagonal here, draw the other diagonal here, here, and here. Lines of the vanishing point. And that's actually going to be enough to figure out where the horizontal line goes through here, where the horizontal line goes through here, and where the horizontal line goes through here. Okay, so we need to get 3 more lines going to the vanishing point and 3 more horizontal lines to get our 8 by 8. In this case, I just wanted 4 by 4, so I'm going to highlight the lines that I'm using. And in fact, if you want to make it look even better, you could color some of them in. You certainly don't have to do that. Any questions about this? What 2 types of perspective drawing have we done so far?
1 point.
We're just wrapping up 1 point perspective. Before that, what did we do?
3, 4,
Just
0.
Well, it's 0 point perspective, but what do we call it? Isometric perspective.
Yeah.
Okay, so in both of those types of perspective drawing, we used the 3 dimensions. And each of those dimensions kind of had a set of rules, how you draw lines that are for each of the dimensions. So first of all, who can tell me, what are the 3 dimensions? Height, width, and depth. Okay, so the 3 dimensions that we've been using are, I have them in a different order here, but width, height, and depth. In isometric perspective, we had rules like the width is a line that goes up and to the right. They're all going in the same direction. They don't have a vanishing point. They're not drawn in perspective, but they're going up and to the right in that hexagonal grid that we had. The height is all vertical lines. The depth are all lines going up and to the left. Okay? So we had specific rules for isometric constructions. Same thing in 1 point perspective. In 1 point perspective, the height is what kind of line? Vertical. The width is what kind of line? Horizontal. Those 2 dimensions are not drawn in perspective, but the depth is drawn in perspective, so lines that represent depth are drawn how? To a vanishing point. So the depth lines in 1 point perspective are drawn to a vanishing point. So in my drawings over there, the drawing that you just did, anything that's going the depth of your chessboard is going to be going to the vanishing point. In that particular picture, you're not going to have any vertical lines because the chessboard isn't going to have a height. Okay? So what we've done so far are isometric drawings and 1 point perspective. What we're going to move into next is going to be 2 point perspective. Anyone want to guess what 2 point perspective means?
There's 2 points for you.
Okay, so we're going to have 2 vanishing points that we're going to use, at least 2 primary vanishing points. And how many dimensions are going to be drawn in perspective? 2 of them. So in 1 point perspective, we had 1 dimension drawn in perspective, the depth. The other 2 dimensions, the height and the width, were not drawn in perspective. Now in 2 point perspective, we're going to have the width and the depth drawn in perspective, and the height is not. So the height is still not drawn in perspective, but the width and the depth are. So my question is, how many vanishing points are there going to be in 2 point perspective? It's kind of a trick question. We have 2. We're going to have a vanishing point for the depth, just like we had in 1 point perspective. We're going to need a separate vanishing point for the width, but we're also going to end up with other vanishing points. It's kind of a tricky question because it's called 2 point perspective because there's 2 primary vanishing points, but there are lots of other vanishing points. In fact, there's infinitely many vanishing points. Every set of parallel lines in the plane is going to have its own vanishing point. The thing is, the width lines and the depth lines are the ones that we're going to use most often, so we're going to use 2 primarily. All right? So, imagine this is let's say 2 sets of railroad tracks running side by side. So I could draw this a little bit better here by throwing in some railroad ties going across here. So we have 2 sets of railroad tracks going side by side, going off into the distance. Okay? And those 2 railroad tracks are going to intersect at a 90-degree angle, at a right angle, with 2 more 2 more sets of railroad tracks. Okay? So each set of railroad tracks here is going to have what? Okay, they're going to have railroad ties. But more importantly, what are those V's at the top? Vanishing points. So the one set of railroad tracks, the yellow ones going off to the left into the distance, they have a vanishing point. I called it V1 here. The white railroad tracks going up and to the right off into the distance, they have their own vanishing point. And so we could say the yellow ones are the depth. Those are the ones that are going away from us. The white ones are the width. Those are the wide ones are going off to the right. And what we end up with by these intersecting lines here are a bunch of squares. So we get a grid 3 by 3 of squares. You guys see that? Okay. So we said we're going to use 2 primary vanishing points. Now, I'm going to draw this picture not in perspective on the board here, and I want to show you something that's going to happen. So what we have is a 3 by 3 grid of squares. In the picture, where are all of these lines going? They're going to which vanishing point? They're going to V2. I'll also call that the right vanishing point sometimes. And then all of these lines are going to where? V1. Okay, so if we're drawing these so that they're not in perspective, all 4 of these lines here are what? Starts with a P. Parallel. And all 4 of these lines here are parallel. Since they're parallel in real life, when we draw them in perspective, they're going to have a vanishing point. Now, we can make more parallel lines in this picture, from this picture. So, if I were to draw this line here, who can tell me how I could draw another line that I know is parallel to it? Make it go where?
Make it start where it starts.
Here?
Yeah.
And go where?
Straight out. Like that one.
This one?
Yeah.
So it's the same line, right?
But
I want one that's parallel to it.
angle,
Well, if it's a different angle, then it's not parallel. From where? Like this corner? This one? And go where? Yeah, if we draw a diagonal. Now, I know that those 2 are parallel. Why? How do I know they're parallel? What did you say, Jamie? Oh, I thought you said something. Kayla? There's no vanishing point here in this picture. Allison?
Is it because they're going off of parallel lines, like off of like the,
Kind of.
in between like the center of parallel lines?
Kind of. Miles? Yeah, I think the simplest way to explain it is because they have the same slope. For these lines, assuming that these 9 boxes here are squares, these lines have a slope of 1. We go up 1 and over 1, up 1 and over 1, up 1 and over 1. And this line here has a slope of 1, up 1, over 1, up 1 and over 1. And we could draw a few other lines in here that also have a slope of 1. And we know that all of these lines here are what? Parallel. Since they're parallel here, what's going to happen in that picture? They're going to have a vanishing point. So if I were to draw in the diagonals here, then what happens? All these diagonal lines here have a vanishing point. It does kind of look like strobe lights, doesn't it? Okay, so what we end up with then is a third vanishing point. So remember when I said we actually have more than 2 vanishing points, but we end up with a bunch of them? Yes?
Could you do that pointing downwards, or would that not work?
If you were to go downward, then they would just spread out. They wouldn't get closer together, but they'd get further apart, so you wouldn't get a point. Good question. Okay, now, let me show you one more set of parallel lines in this picture. If we were to go at a slope of 1/3, which means that if I start here, I would go up how far? Up how far? 1 and run how far? 3. So I would have a line like this. I'm going to extend it kind of far so we can see where it's going. And if I do the same thing here, and the same thing here, all three of these lines are what? Parallel to each other. Now, what's going to happen if I draw those lines in this picture? If I start at this corner, I go up 1 and over 3 and draw that line. I start here and go up 1 and over 3 and draw that line. They're going to have a what? They're going to have their own vanishing point. So we end up with a picture that looks like that. And we have now a fourth vanishing point. How many vanishing points are there going to be? Infinitely many. Every set of parallel lines, so the yellow lines are all parallel to each other, the white lines are all parallel to each other, the blue lines are all parallel to each other, the pink lines are all parallel to each other. Every set of parallel lines is going to end up with its own vanishing point. Now I want you to notice something about the vanishing points. What do you think I want you to notice about them? They're what? Be less specific right now. They're all in a what? Line. They're all in a line. Okay, and that's important. And Miles actually gave away already. What's that line called, Miles? Yeah, that line right there is called the horizon. It already went down. It's dark. Can't you tell?
So the lights came on.
Yeah. That's why we have strobe lights. Okay? So we have a bunch of parallel lines. Each of those sets of parallel lines have their own vanishing point, but all of the vanishing points end up on the horizon. It's kind of cool, isn't it? Sure. This picture looks kind of confusing. I just wanted to kind of get home a point here. We'll talk more about this later, but let's look at some pictures of this actually happening. This is Chicago. This is a picture taken on Michigan Avenue.
Did you take it?
I did, actually. So I'm going to make this picture smaller so we can see what's going to happen here. And essentially what I'm going to do is extend the roof lines. So this line right here, this green line, is an extension of this roof on this building right here. Okay, if I do that again, there, that's an extension of this roof line here. And if I do it again here, that's an extension of this roof line right here. Actually, it's probably more of a window line. There's an edge of the building there. It's kind of a roof, but not really. And I can do it again here. This is the bottom edge of the windows on that building. I can also do it for the roof line on this building. So what are you noticing about all these lines? They all go to the same spot. Now in real life, these buildings are all built in the same direction. So all of those lines are actually what? Parallel to each other. If you were to extend those lines in real life, then they would never meet. If the buildings were built perfectly. If they're built at a little bit of an angle, then they may end up meeting. Okay, but those lines are all parallel to each other. And you can see it going off in the other direction too. So going off to the right, we get a vanishing point for all those parallel lines. But we can extend roof lines going this way also. And guess what we're going to get? Another vanishing point. So this picture here is a good picture of two-point perspective, where we get a vanishing point for the width lines. If you imagine that we're standing here looking at this in the front, this is the width, and then these yellow lines here are the depth. Okay? More often than width and depth, I'm going to just call it right vanishing point and left vanishing point. That way we don't get our dimensions confused. Okay? So we're going to have a vanishing point for going to the right. We're going to have another vanishing point going to the left. Finding a diagonal vanishing point in this case, the vanishing point that all of these lines went to, is a little bit more difficult because we can't really see the diagonals in this picture. Okay, we will use diagonal vanishing points quite a bit though, so I'm going to show you another picture here. I've actually shown this picture to you before, haven't I?
Isn't that in Germany?
Yeah, it is in Germany.
Yep.
Good memory. This is in Stuttgart, Germany. It's in a park, and a bunch of people are playing chess. You can see the chess tables all the way around here, and people are playing. And then they have this big one here, and the people are walking around and playing on the big chessboard. I like this picture because it shows two-point perspective really well. If you extend the grid lines on the chessboard going to the right, and you extend the grid lines on the chessboard going to the left, do we get a vanishing point? Well, yeah, it's not on the picture, but it's actually going to be there. And there's kind of an important point here. for a picture to look realistic, usually the vanishing point isn't in the picture. Did you guys notice in the last one, in the Chicago picture, the vanishing point wasn't actually in the picture? And in this picture here, the vanishing point isn't in the picture, or at least both of them are not. We're going to end up with a vanishing point that is, and we'll see that in a second. But if I make this smaller, you can see that all of those lines do intersect at a vanishing point. And you see that white line on there? What is that white line?
Horizon.
It's the horizon. Now, there's trees and stuff in the way here, but everything below that line is ground. Everything above that line is sky. Right, Kayla?
I was looking at my eyes.
You were looking at the inside of your eyes?
My eyes forced closing like my apps on my phone.
Okay.
And then I was just opening.
Where are we going to end up with another vanishing point in this picture? How could I find another vanishing point in this picture? What could I draw in to find another vanishing point? The diagonals. So the diagonals, and I'm going to be more specific here, the diagonals of the squares, so those chess squares are squares, the diagonals of those squares are going to, sorry, I thought I was going to get that, there they come, they're all going to meet at a vanishing point. That vanishing point has a special name. It's called the diagonal vanishing point. So the three vanishing points that we have in this picture here, this one over here, we're going to call the, oh, that's not what I wanted to do. This one over here, we're going to call the left vanishing point. This one over here, we're going to call the right vanishing point. And this one right here, we're going to call the diagonal vanishing point. Tiffany, pencils down. Okay? Now, this diagonal vanishing point is important because we know that the diagonals of what kind of shapes are going to go to this vanishing point? Squares. Not rectangles, but squares. And that's going to be useful to us. It's going to allow us to construct squares accurately in two-point perspective. All right, so let's go ahead and do that. I want to construct a square here. I'm going to give you most of the time the left vanishing point, the right vanishing point, and the diagonal vanishing point. And then using those vanishing points, you're going to make your constructions. So the first thing I need to do to make my construction, to construct my square, is to just pick a starting point. This is the way we've started pretty much every one of our constructions. So let's start our square right here. That's going to be the front corner of our square. I need some help. What should I do next? And while we're doing this construction, I'm going to go ahead and do the same thing I did earlier and draw a picture of what we're doing that's not drawn in perspective. So what I have right now is just a corner of a square. What should I do? What do you think, Kayla? To where? From where? DIP? Where's the dip? DVP? So if we, let's go ahead and do that real quick. Let's say I draw this line in here. What would that line look like in this picture? Well, all lines are straight. Nope. It would be a diagonal, so it would be going at a 45-degree angle. Okay? We'll go ahead and leave that in there. I wouldn't do that first, and I'll go through this construction again in the order that I would do it, but let's go ahead and leave that in there for now. So we've got that. Now what? What else?
You draw lines from the vanishing points
To that starting point?
Yeah.
Okay, so we'll draw lines from the starting point to the right vanishing point, which in this case right here would be a horizontal line or a line that shows width. And then another line going from the starting point to the left vanishing point, which would be a line in this picture that is vertical or showing height or depth. Now what? Did I say anything about how big our square needs to be? No. So I can just pick an arbitrary point here. Let's say I pick a point right here, which might correspond to a point like right here in the picture. what can I do then? Miles?
You make another line to your right vanishing point.
Okay, so we could draw another line, construct another line from that point to the right vanishing point, which would correspond to a line like this. And then what? How do I make sure that it's a square? Miles?
You draw a line going from the left vanishing point to the
Through the diagonal? But the diagonal's a line, so where on the diagonal should I go? Okay, good. So what we're going to do here... What we're going to do here is we're going to draw a line in this picture that corresponds to a vertical line going through here. Okay, now that line should go toward what, Miles? Tell me again. To the left vanishing point, good. So we're going to draw a line from the left vanishing point through that intersection until it meets the side there. And what we have now is a square. So what we have right here is a square. And I know it's a square because this diagonal line goes from one corner to another. Okay? If the diagonal didn't go through the corner here, then it wouldn't be a square. So let's go through that construction one more time here. And like I said, I'll kind of explain a little bit more how I would do this. So from my starting point, I'm going to go, and I'm not even going to put the point on here, but I'll just draw the lines. So from my starting point, I'm going to go to the right and the left vanishing points. Now I need to decide how big I want my square to be. I can pick any point along this line or any point along this line. Let's make the square a little bit bigger here, and I'm going to pick a point along the right line right there. So we're going to end up with a pretty big square here. This might be something like if you're standing by a football field, how it would look if you're standing like right next to it. Then it would look pretty big. How do I decide where to draw this other line going this way? How do I know where to draw that? Austin?
You need to draw the diagonal.
Yes, exactly. We need to draw the diagonal. So go from that starting point to the diagonal vanishing point. That gives us an intersection right here. And then from the right vanishing point, we go through that intersection. And we get a point like that. I missed it a little bit there, sorry. But you get the idea, right? Okay, one more thing I'm going to ask you to do, and this is going to be kind of on your own. If I told you that this was a square, I know it doesn't look like a square, but if I told you it was a square, what could you do to figure out where the right vanishing point, the left vanishing point, and the diagonal vanishing point would be? Miles?
You could start at the bottom corner and then make a line going through the
Okay, so you could extend the lines, is that what you're saying, basically? So you could extend this line right here, and you could extend this line right here, and you could draw the diagonal here, and draw those off a little bit. What else? Where? So what you're going to end up with, this is going to be sloppy, I'm apologizing for it right now, but what you're going to end up with is something that looks like this. How do we know where the points are going to be? I'll give you a hint. We got to extend the other sides also. Then draw the horizon, and then that gives you the diagonal vanishing point in there.